Hello, everyone. Thank you for coming to my talk. So I will talk you about how to use non-standard tooling and security researcher tooling, especially for debugging the Android application. So by using such a tool as called Frida. Before we get started, I'm just quick facts about me. I came from all the way from Tallinn, Estonia. For anyone who don't know about this small country, yes, it's a small country with only 1.4 million population, and it stands between Norway, Sweden, and Finland. I'm Android GD and from time to time security researcher, doing from some time just out of curiosity. And I'm Android engineer at Bolt. So what is the Bolt actually? There is some naming clashing with some Bolt companies in the United States, but to be more precise, I worked before in Alibaba and Yandex and currently working at Bolt. So Bolt actually, it's a ride-hailing platform for especially Europe and Africa, where we do have multiple services, not only ride-hailing, but also scooters, e-bikes, car sharing, food delivery, and grocery delivery as well. So that's pretty much like what we're actually doing. Depending on the region, we have multiple businesses, and not all of them are presented in all the countries. Okay. But before we started, just agenda, right? So just to make it clear, first one, what we will discussing about. First one, we jump into the problem, and we'll understand what's the problem do we have with our app. The second one, what is the instrumentation essentially, and we'll understand what is the definition of the instrumentation. The third one will discover the Frida as a tool, and we'll figure out what's the capabilities does it have, and what is actually tool. And the fourth one is demo time. I prepared a small demo for you, how you could make your debugging a bit easier than just jumping from the scratch. Okay, before we starting doing something, first one, it's a disclaimer that because this topic touches a bit reverse engineering techniques. And the first one, all the experiments that we are doing for educational purposes and currently with your own apps. The second one, always respect the intellectual property rights of others. And the third one, check your local laws, regional laws. Is it possible for you to make a reverse engineering or not? Especially for some of the region, it's forbidden. So, okay. But first, right, what's the problem? Exactly. First one, please raise your hand. Who has anyone ever fixed the bugs in your app? That's obvious, right? Yeah, sure. So, but let's understand how it's usually done. When we do have a source code, everything is clear, right? We're just watching the Firebase logs, and we just trying to investigate by some sources. But what if the bug is only appeared in production and only replies in production? I don't know, maybe you have a startup where you're deploying a lot, and you're making some fast coding, and you delivering some stuff in production so fast, and you try to get an MVP instead of stability. It's from time to time happens. Okay, the problem, what's the main problem in the production application? The first one is that we don't have Android debuggable true. What does it mean? It means that if you're compiling your application, APK file or AAB file, it's already disabled as a debugging unit. So it means that you never able to attach to a debugger in a normal mode. The second one, the Firebase logs, it's perhaps you may miss some of the logs because you can't in advance cover all the files, all the lines that you're interested in by logs, and You just log this information. And the last one, investigate sources. Sometimes it's flying blind. It's a blind way that you even don't know what this bug came from, because maybe you have a huge file with your code, what is it, like spaghetti one. And yeah, but what else? What we could do and apply for your app? And there is another way with the Frida. And before we starting jumping into the Frida itself, let's recall to the basics. What is instrumentation? Yeah, what is instrumentation? Instrumentation is essentially collecting the program execution information in order to find some useful information, such as bugs, errors, or collect tracing information, performance metrics, or something like this. It doesn't matter. Instrumentation is just a kind of umbrella of the terms. And there is two modes how to instrument the code. The first one, it's a source instrumentation based on the sources, and the second one, it's a binary instrumentation without any source code in your hand. So, what is this source instrumentation? It's kind of process of software introspection while we have based on the source code and collecting information based on the presence of the source code. It may be Android Studio Debugger, which is based on your source code. It may be GDB, maybe somebody knows about this, and any sampling or tracing tools that presented for every of other platforms. And yeah, that is one of the example at the bottom, which is you put the pin, the red one pin, and you could just debug your app based on the source code. And the binary instrumentation is also pretty much the same as the source code, but without presence the source code. So obviously, and it runs on top of your execution at the runtime, and you could attach to the runtime kind of parts or the whole program, and in that time means source code just unavailable for you. And it's a strace tool, or even Valgrind. It's one of the old tool for debugging LLVM compiled code, or the Frida. So here, just for instance, the strace for Linux terminal command, which is ls, means we're trying to run it, and we see all the system calls that came after you start running this, and it explains how does it work. Okay, but what's about the Frida tool I mentioned, right? And the Frida, not this painter lady, actually. And Frida, what is it? Frida, it's a dynamic instrumentation framework, which was created for reverse engineering originally, and it could penetrate in your source code binary. It's injecting small script snippets, or even not small. Sometimes it's a huge one by Chinese colleagues that guys tries to penetrate the apps, and it gives you a lot of possibilities how to what to do with your app essentially. And it's also in interactive mode. You could somehow I don't know, put some information in your runtime, and you could receive it back. And yeah, the name comes from a Mexican painter. His name is Frida Kahlo, and one of the famous Mexican painters. So, and the website is frida.re. So it can instrument any process, even the processes which is debuggable faults in Android. It's super flexible, to be honest, and it's scriptable. You could choose using the Python or JavaScript, and right now you're also able to use a TypeScript. And it works with the Android and the iOS, but to be honest, it works across all the majority of the common platforms. You could even use it for desktop processes that you're developing by some reason, I don't know. And Android version requires root, but not always. There is some part of the Frida and the runtime that is available to attach without root, but it's highly limited, and we will not cover this part. We will just using the rooting and rooted emulator. Okay, what Frida can do for you, right? So it could attach to your process first and make the things such as function hooking, function calling or recalling. It could kind of replace your argument on the fly if you want to, I don't know, just to put some of the experimental value instead, the real one that is passing in your method or even constructor or something like this. It also could make some memory modification. It's one of the hard thing that you could do, but it's hard, but yeah, it's possible to do. So let's jump into the mechanics, how the Frida works. And actually there is two entities, which is desktop and your mobile phone. And there is the APK code on your app on the mobile phone. And there's a Frida script on your desktop that you're writing and describing only hooking logic there. And there is obviously communication between the desktop and the phone via ADB. And this runs on top of the Frida node and Frida core engine that is installed on your desktop. And yeah, you need a Frida server. It's kind of observer and the watchdog on your mobile device that will kind of perform some communication between the desktop. And the small Frida fact is that this game calls Dark Souls. And fun community fact is that first version of the Dark Soul was released with a huge amount of the bugs. And this box was fixed, especially graphics box, graphic card box was fixed by community freedom. And so yeah, that was funny, but first like fixes came not from original developers, but from community. And yeah, the 60 FPS version was created by community as well. And it was patched by Frida and kind of was upscaled by frame rate. So that's the fun facts about the Frida, and yeah, it's the kind of demo time. I have prepared a small recording of the demo for you, but first let's figure out what's actually the case. We in our ride-hailing app, which is essentially super app, we already have their functionality with the scooters, have a small bag that actually, as you can see here in the top left corner, that is a my coordinate, and the bottom right corner is the scooters pins. It's a small one pins in the middle list in the C. Instead of having my scooters in the city where I'm sitting in HQ, I kind of like find it in the middle list C. So and yeah, let's create a fictional bug. It's a kind of task to make a bug for you. And so what we will do, we just will swap the latitude and longitude coordinate, and we'll kind of make a fictional bug as a backend response for us, some invalid data. And we'll make some logging of our incorrect output and try to figure out is it correct or not. And the third one, we will try to fix the bug in place to figure out, to make sure that this is an original problem and we could fix it in the backend. So, and yeah, I will switch to the mirror mode. Okay. Now you should see my screen. Okay. And yeah, let's get started. So, as you can see here, that is a typical JSON model, right? It's for like, deserialization of your JSON response, super easy. And I have a network model that describes where the scooter take place with the 2 points of coordinates. double coordinates, lat and long. So easy. And what we will do with these coordinates, we will create a fictional bug, and that means that we need just to swap the coordinates, latitude and longitude. And yeah, we do have a mapper. It's a typical mapper that presented in majority of the apps for transforming the network model to the main level module. So, and we will try to log from this convenient point. So that is a method map that we have, and we have input parameter as a network model that was that I showed you before, and we as output have a rental vehicle. It means that it's a model for displaying for the UI layer. So, and we're passing the location model that we need to actually mock, kinda hook, and replace. An location model is just a stupid model with a latitude, longitude, accuracy, and some precising mark. So first, let's just replace the swap the latitude and longitude. We just will create this. It's easy to invent the bugs, right? Okay, so, and what do we need to do? Next, we need to run the emulator. Yes, I have a pre-rooted emulator already on my machine. I will show you the kind of link to the GitHub page where you could easily run the script to run your emulator. So, and yeah, during the emulator starting, we will create a script.js file that is essentially describing the logic of your hooking process. And it's easy. You need to provide java.perform function on the top level of the JavaScript file. And so we need to describe all the logic here inside. And it will, yeah, as you can see here, I have a rooted emulator where the Magisk, it's kind of root manager program for Android, have already. So, and yeah, emulator is rooted. So, okay. First, what we need to do. First, we need to run the Frida agent. Frida agent, as I said previously, it's just a tool which observes all the changes, which is delivers, making input and output, some I/O to your application, to your running process, and performs communication between the desktop. So we need to run ADB shell first, and then we running superuser. Yes, superuser was granted. So then we need to. I already have in the data section, data local TMP directory, the Frida server, and I've run this. I'm just starting it as a usual Linux program, and then I want to make sure that Frida process is running and everything just fine. Yes, the same process ID here, as you can see. So, and what next? The next we need to run to start actually the desktop part where the Frida, you need to pre-install this from, I don't know, from Brew, from many other places. Actually, there is a good guide how to install the Frida. I will provide you a link. And yeah, you need to start Frida on your desktop. And we're running it in a -u with -u options. It means that it runs on a device, in a USB device. No pause means it will not block the UI thread after we starting running the Frida process. And -l means that the pass to our script, it doesn't matter. It should be just a pass to your newly created or even existing script. And -f, we are passing the package name, which is actually, you already know in your app. So it's a pre-live app. So since we're running this command, as you can see, the bold app successfully started. So, okay. From this point, we already running the process of our app with the debugger attached. It doesn't matter what the app you're running. white touched, as you can see here, we spawned the process and resuming the main thread. And now we could make some interesting stuff. Okay, so as I'm already provided information about that, we have a mapper, and we can perform the logging of that mapper. So let's try to understand from what point we receiving invalid coordinates. We already know that, but yeah, let's try to find just to log the output during the mapping process. Before doing that, we need to, what do we need to do to make it done? We need to define method signature and the class path for our mapper, and it's super easy. You need to provide full class path in your string and search the Java class. You need to call the java.use. Then you need to copy and paste your package name and yeah, and actually the full class path. So and you could extract it into the variable. And since that point, you already kind of grabbed the class type in your script. The next one, you need to override the map function. It means that you need to create a function inside your map class, just by describing it here, and call overload method. Overload method will include all the signature and input parameters means, and the output parameter as well. We're just copying and pasting all the parameters. So in a fast way. Okay. The next argument is string. Okay, Java length string. Okay. And here, after this, we just typing implementation. It means that here we re-implementing our function on the fly. So, and inside the function itself, we could do anything, whatever we want, and provide something that we think it's useful for us. So, yeah, let's try just make some proxy with the script. We're just doing a proxy, literally. So you can see here, we're just recalling this .map, which means it will call original function which presented in your class, mapper class. So, and we're passing the parameters that we getting from the runtime. And let's press the button with the in a tile on the bottom sheet with the scooters functionality. And let's make sure that everything works fine. Nothing goes wrong here, and yeah, everything happened as it's happened before. We don't see any scooters on the screen. Okay, let's make some more stuff with the logging. We just provide the console output to figure out actually what's the problem here. Okay, we just making some logs by calling the model and just fetching the appropriate fields. Okay, it takes a bit time to make logs with the GitHub Copilot. It's probably faster than should be manually. Yeah. Okay. Model.longitude.value. And here we go. Let's try and let's see oh yeah, it appears. As you can see at the bottom of the console, we already got some of the fields that we provided. And let's try to find in the Google Maps what's the coordinates actually, right? We're interesting what is the coordinates we're getting from the server. Okay. Google Maps has a functionality to provide with the comma separated latitude and longitude, and we could put it in the search field and you will see exact point where it's actually pointing, referencing on. Okay, it's somewhere. Yeah, it's somewhere in the sea. So let's try to scroll a bit. Okay, So yeah, it's somewhere in the Middle East, in Oman Sea. Okay, let's just imagine, yeah, we received the coordinates, invalid coordinates from the backend, and here we could see that in the production, someone on the backend just messed up with the coordinates. Okay, let's try to validate our theory and create some other script in the same file. We just will wipe everything here and we'll make some hooking stuff with the reinstantiating the whole rentals vehicle and the whole location point. So first one, we need to do the same thing with the finding the class with the full class path by using the java.use and provide the string. So the next one, we need to figure out the rental vehicle constructor. What does it mean? It means that we're running the Kotlin and location model data class generates by default maybe one, maybe multiple constructors. We even don't know in advance. And what do we need to do? We're doing the same things by providing the full class path. Yes, with the same name. And what do we need? How to understand what's the constructor actually to use? We could do actually useful things, but before that we are just initializing the whole class. $init means that we are instantiating the new instance of the class. But to understand what is the constructor that we need to use, I'm just using the Kotlin bytecode and decompiling the class from the Kotlin to the Java. And you could easily find exact constructor that you are able to run, to start, and to call, and to instantiate your data model. So it's easy. I think most of you are already familiar with that functionality, especially for then, since the time the Kotlin just launched. It was a long time ago, but anyways, so this was, you need to understand what's the Java code you're getting as output. And yeah, what do we need to do? We need to overload the constructor arguments. We need to provide the whole signature. It means that we're providing the types, primitive ones, and the class passes with the built-in Java types, and as well all the parameters that we're passing from all code. So, and yeah, here I'm just copying and paste all the signature and yeah, location model, yeah. And after that, we overloaded our constructor. That is, yeah, okay, yes, it's a primitive type, integer, and what else? Yes, Java string, the last one. And we just describing implementation of our constructor. We just re-implementing whole constructor things that we interesting. So, and I'm passing the parameters name because it's mandatory to have proper names here by just copying and paste. So, okay. It's more convenient to map all the fields that came to you into the Frida script that is clearly mapping on your naming inside the project. Okay, so here I'm implemented the function, which is actually constructor. And what I need to do, I need to pass and recall all the original constructor and pass the swapped coordinates. So here I will just return this $init, and then I will pass all the parameters. So it's ID, name, location, charge, and icon URL. Okay, it will stand as a proxy, as previous example. It will just log all the things that came into the constructor during the instantiation. So super easy. We just will see all location models that came here during the instantiation. So let's try it out. Yes, let's name it old location model first. And yeah, one important thing is that I didn't mention is that everything that you're writing here, it's hot reloaded. That means you don't need to reinstall or relaunch your app. It's all the changes applies automatically if you're pressing the Command S or you just switching the windows. So as you can see here, all location model appears, and latitude and longitude that we wanted to see is here. So, and what do we need to do? We need to reinstantiate the location model class, do pretty much the same things with the $init and overload the constructor. So yeah, we need to. Oh no, we don't do that. We just need to put to create a new instance and put the two parameters, which is only latitude and longitude. Yeah, here class pass dot $new means that we instantiating the new class. You could instantiate any class, whatever you want. It kind of, yeah. And let's name it properly. Yes, a new model. And we could log it as well. New model, nice. Let's return to the, return to the screen. As you can see here, old and new location model successfully, but we need to swap the coordinates back to get some effect of the changes. And yeah, we need to pass the new location model that we instantiated, not only the log, but also the pass. As you can see here, we are passing inside our new constructor call that we overrided, the new location model that we actually re-implemented, reinstantiated in other way. Okay, let's rerun and let's see what will happen. Okay, yeah, it appears the scooters is there. Scooter's there, and everything works fine. So yeah, and you could see all the scooters in the map instead of the Omancy. And yeah, by the way, in our testing environment, we do have a Batman location polygon just for fun. Okay, what else? What else? What's the more top-level cases you are able to do with the Frida? It's not only the hooking and replacing something, but also there is so many things that community already created for you. And one of this is disable SSL pinning, just for testing your pre-live environment. By some reason, if you are using your SSL certificate pinning in the pre-live, you could somehow disable it. Also, you could intercept and modify OKHTTP calls and any other calls, to be honest, because community already created a decent amount of the tools for playing with the responses as well. And you could intercept it and replace on runtime. And just for instance, location spoofing, if you find any not a trivial way how to use the mock GPS, you could also create some scripts and tooling for it on top of it. And you could also penetrate all the things like system calls, like GNA calls, Android jar, STD library, and whatever you want. And yeah, useful links, as I've mentioned before. The first one is a Frida installation process for Android. It's straightforward and really easy to do. So there is kind of 5 or 6 steps that you need to make down. The second one is the emulator routing script. It's a small script that is just performs, which just connects through the ADB, performs some tricks with the your real image and on the directory of the emulator, and yeah, it runs the rooted. It creates your it turns your emulator rooted. And the third one, it's a collection of the goods. There is a lot of things that community already have, and it's the awesome Frida link that I'm actually using a lot. So, and that's it. Thank you.